Thank you. Good morning. Happy Halloween. So Bob Ross used to say, we don't make mistakes, we have happy accidents. So I'm going to tell you about a happy accident that turned us into chaos engineers. So hi, I'm Paul. I work at Stripe. Stripe builds economic infrastructure for the internet. I work on the cloud team there, so our team kind of ships cloud providers to the rest of the company so they don't have to think too hard about it. We're hiring, so let me know if you are interested in that, but enough about all that. So here's some topics, spoilers, what I'm going to talk about. So first, I'm going to talk about the problem that we saw with our infrastructure. Then I'll talk about the solution we designed to try to fix that. Then I'll talk about how that solution broke in exciting ways when the rubber hit the road. And then I'll talk about what we learned. So the first thing I want to talk about is instance age. What is it and why do we care? So when I say an instance, what I'm talking about here is a cloud-hosted virtual machine, an EC2 instance, for instance. And when I say age, the time since launch, I don't mean the age of the actual hardware or like the uptime. I mean the time since we called like the launch API call. So here it is in picture form. So we have an instance that's just launched. It's on the left in this sort of young area. And then as time goes on, it scoots over to the right as it gets older, months later. And then eventually we want to terminate this machine and replace it. We have then created a new machine, and that old machine goes away. So here's an artistic rendering of what our instance age histogram looked like at the beginning of this project. So we can see some landmarks along the way. We had launched a Hadoop cluster at some point in the past, and those instances hadn't really been touched in a while. There was some large migration where we moved everything, and then that was the last time we moved some particular hosts. And then we had that sort of dark corner of the infrastructure that nobody really wants to touch. It gets a little scary over there. And so what's wrong with that graph? What didn't we like about that? So I like to think of replacement as a sort of fire extinguisher for when the instances catch on fire. And not sort of metaphorical fire here. When they start acting funny, it's nice to be able to replace them. If it's in an incident, being able to replace an instance is a nice thing to be able to do. However, if it's been a while since we've replaced that machine, it's possible breaking changes have landed in that instance's provisioning flow. In that case, our fire extinguisher has all of a sudden become a fire of itself. Now, instead of having the single problem of this instance behaving badly, we now have two problems because we replaced it with one that is totally broken. And a younger instance, one that we replace more frequently, would be less likely to run into that problem. So another problem with these old instances is accumulated state. So on the left, we have this freshly booted instance. Maybe it looks more like a chicken. And then on the right, we have this instance that's been around for a while. It's been accumulating state, a lot of changes stacked on top of each other, and ends up looking more like a duck. Will replacing a chicken with a duck work? I don't know. Who knows? It's hard to tell ahead of time. The last problem that we wanted to solve with old instances is related to security. So the first problem is that if a host was compromised, if it has a long age, that's a lot of time that it can sort of wreak havoc on the infrastructure. And the other security implication is around patches. So if we have a vulnerability that's been announced, the patch has been released, let's say it's been released about 10 days ago, instances that have been launched since those 10 days we feel pretty good about. They've picked it up during their provisioning, they've incorporated the patch, they have the latest kernel security patches and all that. But the instances older than that are a little bit more of a question mark. We have a process for updating those, but it's going to take work, and it's going to take work to then confirm that those patches have actually successfully been applied. So what we'd like is to sort of push all these instances over into that green happy zone where we feel confident that the patches have been applied. So to review, the three problems we had with old instances are replacing them might not work, replacing them might bring up something that behaves in a different way, and replacing them, the old instances require more work and are less confident about them having the correct patches applied. So now I'll talk about the system we designed to try to fix this, which we called lifespan management. So the goal of lifespan management was to set a maximum instance lifespan. In our case, the default was 7 days. And then we would enforce that lifespan by replacing instances automatically. So it had three components, an ASG or an auto-scaling group, our Terminator, which was our graceful shutdown service that we run on all of our hosts, and then this lifespan manager, which is a stateless cron that would just wake up on a cadence and terminate hosts. So what is an auto-scaling group? An auto-scaling group is a cloud provider primitive. In this case, you give it a size, and if those machines get terminated, either hardware failure or we terminate them, the auto-scaling group will spin up some replacements. In this case, we've had 2 hosts that have been terminated and then 2 new hosts that get launched. Now, what is the Terminator? This is our graceful shutdown service. We run it on every host. The way this works is we make the terminate API call. AWS then invokes that Terminator service and does what it shaves whatever yaks, does whatever cleanup it needs to do while it tells AWS, wait to terminate me. So it's sending heartbeats, and eventually, once it's done doing its cleanup, it gives it the thumbs up, and then AWS proceeds with the shutdown. The last piece, the lifespan manager, this is the stateless cron job. We have this auto-scaling group. It checks that they're all healthy, and then it looks for any instances that are over our allotted lifespan. And it'll terminate one, wait for the auto-scaling group to spin up the replacement, wait for that replacement to be healthy, and then you rinse and repeat and keep cycling through the older instances. So we had a design decision to make about replacing the machine. We could either launch a new machine, wait for that machine to be healthy, and then replace the older machine, or we could do strictly terminate, just terminate only and let the auto-scaling group handle the replacement. There were some nice things about doing the terminate only is that we didn't have to mess with the size of the ASG. We could keep our system very stateless. So it just had to wake up and check the state and perform some actions. So we ended up going with terminate first. And another benefit of that was that we wanted our systems to be resilient to a single host going away because hardware failures do happen, and we want that to be a case that we are kind of sure that we're resilient to. And so you throw in some jitter, and all of a sudden we have a system that is randomly terminating machines all day. And it's starting to look a little bit like a chaos system. And we sort of backed our way into this. And we figured there was no reason we couldn't achieve our instance age goal and also get the benefits of some of this chaos fault injection. But we were being pretty gentle with it. So we were, doing this graceful shutdown. We were checking the health of the auto-scaling group. We weren't kind of just randomly terminating machines. So we figured it wasn't that chaotic, and maybe it wouldn't even be that noticeable that we were doing this. We were only going to terminate a couple hosts at a time, that kind of thing. So now what? We had designed the system. We had, run it on some hosts in QA, and we wanted to roll it out to, the rest of our fleet. The first step for us was to come out with a rollout plan. So we broke up our workflows by labeling them into different categories that were more or less eligible for this lifespan management. We had the stateless host types. These are the ones we felt pretty good about. We just had to make sure they could drain their existing requests and then replace them. Stateful automated, these were ones where the host had a terminator, it had a graceful shutdown script, but it could be done automatically. We didn't need a human involved. And then we had these requires operator ones. These are the ones that were a little trickier to manage. We needed someone to be watching those. We either hadn't automated them or it was going to be a lot of work to automate them. So with that, we decided to target the stateless host types, and we started rolling it out. As automated termination, what could possibly go wrong? It ended up being a year-long journey. It took a lot longer than we expected. So this graph is sort of our adoption graph. We have the blue hosts are the ones that have lifespan management enabled. The red hosts these are not hosts, they're host types. But the red is ones that were eligible, and so that's kind of our adoption ticking up over time. And then the yellow ones are those stateful hosts that we didn't target for this initial project. So next I'm going to talk about, I'm going to tell you 5 stories about what our chaos system was nice enough to teach us. The first thing we learned was how not to health check. So one morning we got this message of, all of our LDAP servers are down, we're locked out of QA. This was really strange. We had health checks. We were being really gentle with our chaos. It seemed odd that we would have terminated all the LDAP servers. It turned out they were still running. There was 4 LDAP servers running, and they looked and sounded like LDAP, but except for the LDAP part. They weren't running LDAP. Kind of important. We started to dig into this, and we looked at how our lifespan manager was doing the health checking. And so it was, it would ask, is this auto-scaling group healthy? All the hosts would report, I'm running LDAP, that health check is passing, and then I'm not in maintenance mode. So we had this maintenance mode health check that was across all of our hosts. And it said, I'm not in maintenance mode, and that's a passing health check. So then we had this sort of broken host that came up that just said, I'm not in maintenance mode, everything looks good here. And the lifespan manager said, great, nothing's failing here, so I can continue terminating. And then 3 terminations later, we have, all of our LDAP hosts are not running LDAP. So we learned from that is, 0 unhealthy health checks does not mean that the host is healthy. So we had kind of a bad default here. Because that maintenance mode health check was available everywhere, we chose that as the default health check in your list of health checks that we would assert before terminating a host. And so it was a convenient default, but not a very useful default as we kind of saw here. And we didn't have the appropriate nudges to teams that were onboarding onto this project to pick a health check that made more sense for their service. It was very easy to just get into this state where you were just checking the maintenance mode health check. And so having that pre-existing knowledge, once we configured it all, the lifespan manager was able to know what services should be running on the host rather than what host services, rather than just checking for 0 failing checks. So this is what it looked like after our fix. So the lifespan manager is actually checking explicitly for LDAP to be running, and if it sees it not running, it pauses and doesn't, cycle through all the instances. The next story is going to be called RIP Kubernetes Workers. You can probably guess what happened here. So someone coming to our channel again, the Kubernetes workers were going down hard. So I'll go back to our graceful termination system. And so what's supposed to happen here is we send the terminate API call, and we invoke this graceful termination script, and eventually, once it's done, then we continue with the termination. What we saw happening was the Terminator was basically being skipped. It was more like pulling the power plug out of these instances. And this was really confusing because we had tested this, tested terminating these Kubernetes workers, and they had done the right thing, so we weren't sure exactly how this had happened. It turns out there were 2 terminate API calls. They look very similar, but in fact do something slightly different. So the one that we were running from our laptops would do the right thing. It would invoke the terminator, it would send the heartbeats. Once it got the thumbs up, it would cycle out the instance. When the one we were invoking from the lifespan manager would behave more like a hammer and would just kind of yank the power plug out. This was a little confusing because the Kubernetes workers weren't the first workload we had on this on the lifespan manager. There were other hosts that even had terminators running. It just turned out that those hosts either didn't care whether their terminator actually successfully completed, or they ran so fast that it didn't matter that we were yanking the plug so quickly. So what we learned from that was to kind of track the feature usage, so if we were invoking the terminator to actually check that it's fully completing, and not relying on people that are implementing the terminator to ensure that theirs was actually running. And the other thing we learned was that it was important to make the chaos really easy to turn off. So this situation happened. I was in jury duty, and I sort of came out of the courtroom and was scrolling through Slack to see all this coming down. And thankfully, somebody was able to find the runbook and shut down the chaos before we got through all the Kubernetes workers. So the next scenario I'm going to talk about is called the Blackhole Scenario. So this is the last time I'll put this slide up, I promise. So we're going back to the Terminator, but this time I want to talk about those signals it's sending. So it could send a heartbeat to say, please wait to terminate me, or it could send a thumbs up to say, okay, now I'm okay to be terminated. But there was no cancel. There was no, wait, I actually don't want to be terminated. So once you sent that terminate API call, you had sort of crossed the event horizon of the black hole. There was no escape. That instance was being terminated. This was not a great experience for users making their graceful termination scripts. If the script exited non-zero for whatever reason, we would just shut down the host. If it timed out, the default was a couple hours, but if they, for whatever reason, their script was taking longer, we wouldn't handle that well. And then if we hit rate limits on our API calls, the heartbeats would start getting dropped, and the instance would go down as well. And it was sort of like our lifespan manager was saying, the terminations will continue until morale improves. It would just gladly keep cycling the instances without caring whether they successfully exited their terminators. And we hit this fork in the road where, on the one hand, the graceful termination was sort of a lie in terms of how actual hardware failure would work. You don't get to abort a hardware failure. You don't get to, say, wait, no, this isn't going to work for me right now. It just happens. On the other hand, our original goal was actually to reduce instance age. It wasn't around simulating hardware failure. So we ended up deciding to make the user experience a little better, a little more gentle in the chaos in order to achieve our original goal of reducing instance age, so we could get broader adoption and make it a little easier for people to work with. So what we ended up doing was we called Touch Termination. So before we even talked to the AWS API, we would invoke the Terminator ourselves, wait for that to complete before we sort of entered that black hole of actually terminating it. And because it was, we made our Terminators idempotent, if you invoked it twice, it would just say it was already done, and we would continue down. So we learned there was kind of in line our incentives. Our goal was actually lifespan, reducing the instance age, which was not necessarily simulating hardware failure. So our goal was aligned with making the user experience better for the users of the system. And also, systems vary a lot. Some systems really cared about their terminators, and some systems didn't really care. It was more best effort. So it was useful to know that some of these workloads really did want a full graceful termination. The next story is about a self-service sort of gone wrong. So if you look back at our adoption graph here, and we zoom in around January, you see this really sharp uptick in adoption. And you'll also remember that was around the same time that Spectre Meltdown came out. So we were filing tickets with teams to say we've set up your instances, so all you need to do is reboot or replace this instance, and then you'll get the latest kernel patches. And if in the ticket we said, if you never want to have to think about this again, if you don't want to have this work on your team anymore, you should think about enabling lifespan management, which had the intended effect of getting us a lot of self-service adoption, but it turned out we weren't well equipped to handle that kind of self-service adoption. So we fell apart in sort of three different categories. The first part was around turning it on. So someone would come into our channel and say, I want to turn on lifespan management. We'd say, great, let me show you how to do that. And we'd give you this wall of text, everything you could ever think about lifespan management. And they would kind of look at us and be really confused about what am I supposed to do with this? How do I turn this on safely? What are my responsibilities? The next category was around who does what, what were the people's responsibilities during this. So someone would come in and say, what happens during termination? What am I supposed to do? What am I in charge of? And depending on who they got on our team, they might get a totally different answer based on who had been interacting with termination more recently or which parts of their systems they were more familiar with. And so we might just ramble kind of a little bit incoherently about how termination worked and then, try to explain it to them, and then, they would be increasingly frustrated. And then they'd ask, okay, so that's great, that's all that happens during termination, but why should I care? What parts do I need to do? And we'd say, great question. We don't have that really well documented right now. And the third part was around false alarms. So I was really surprised how quickly everyone learned about the lifespan management system and how quickly everyone learned to blame it when something went wrong in their system. So we'd have someone come in and say, something's funky in my system. Did lifespan management just mess with it? And we'd say, okay, yeah, sure, let me check. We check our logs, we do some AWS API calls, check our metrics. And, it would take us a couple of minutes to assemble the right picture of that. And then we'd say, great, lifespan management did not affect your service. And then they'd ask, okay, well, what did? My service is still kind of acting funny. What was the actual thing that caused it? And we'd say, I don't know. We had been spending the time ruling out lifespan management. We hadn't been spending any time investigating what had actually caused it. So now I'll talk about how we changed to address those situations. The first was for our onboarding, we switched from this sort of wall of documentation into a flowchart that sort of covered the 80% case. So we had a series of questions that you would answer, and you get directed to different configuration settings for the lifespan manager so that you could turn it on more safely. So our users felt more confident about turning it on. We felt more confident that they were turning it on safely. And then we had for a couple of sort of escape hatches of, if you really were in a weird scenario, you should come talk to us and we can kind of consult you more. Part two about who does what, who's responsible for what, we made a really explicit timeline of all the things that happened during termination. So you could, when do deploys stop hitting the host? When does it drop out of service discovery? When does the host actually go away? And then when does it come out of DNS? So, and this let us explicitly say this is the timeline, and for most people that was enough, and they said, okay, great, you're doing the things that I was worried about not happening for my service. And then for those people that needed something a little bit more custom, they knew the knobs they had to turn rather than having to rely on someone pulling it out of their head every time they had a question. The last part to reduce some of the false alarms, we made a short link, go wide dead, and then you would give it an instance ID, and that would lead to a dashboard that aggregated our three sources of information and would tell you not only whether the lifespan manager did it, but also whether the lifespan manager terminated that instance, but also whether who actually did it. So if it was someone else on your team, or if it was actually a hardware failure, you would get that information rather than us sort of leaving you hanging before that. So what we learned there was make it easy to adopt safely. Explicitly state the contract of who's doing what during a termination event, and then make it really easy to rule out the chaos, because that's going to be the first thing people think of when an incident is happening. So if you can make it easy for them to move on to what is actually causing the problem. The last story I want to talk about is death by 1,000 JIRA tickets. So the lifespan manager would encounter some errors occasionally. It would have a ASG that was unhealthy, and we didn't have all the context on these systems, so we wanted to farm those out to the teams. And being engineers, we thought, why don't we automate this? So we would take the alert and turn it into a ticket. And it turns out it turned into a lot of tickets. And these piled up, and our user teams were kind of frustrated. It turns out it's a lot easier to automatically open tickets than it is to manually close them. So our customer teams were a little frustrated with us. They would get these tickets. They wouldn't really know how important they were, or sometimes it would be, I just replaced the instance and the ticket goes away, but maybe that actually didn't fix the problem. And we lost a lot of trust there, because if a ticket is flappy too, maybe it closes itself, then they immediately learn to ignore that ticket, because it's not going to be something they need to worry about. So we learned, we changed after this scenario was to start filing tickets against ourselves first and automating as much as possible from there. So if we were getting the tickets, we felt the pain immediately, and then we could try to automate the weird cases that we saw and make sure that it was really needed the context of the customer team before we started filing it against them. And one of the things that this showed was that we had these sort of 1% failure scenarios in our provisioning, which used to not happen that often, and if they happen, you would just replace the machine again and it would be fine. But when we sort of 10x'd our amount of termination, and so these 1% scenarios were then happening all the time, and they would wedge our system. So that was what kind of prompted us to automate more things and then insert some retries into the termination. So if we did end up into that sort of 1% case, we would not file a ticket and actually just move the system along. And the last part was about measuring the quantity and reliability of tickets. When we first started filing these tickets, we didn't have observability into how much toil we were causing teams. And this is still sort of a work in progress of how do we measure this and make sure we aren't overburdening teams and make sure that we're sort of being more empathetic in our ticket filing. So that was the end of the story. We ended up calling it done around when we had all of the stateless host types onboarded. We ended up at the end switching from more of a self-service model to a white glove sort of onboarding model. So we wanted to get more people onboarded so we could move on with the project. So here are some takeaways. What automation problems can you solve with a little chaos? Even our gentle chaos, is very sort of gentle, careful chaos taught us a lot. And having the system reduce toil for our customer teams made it much easier to sell than sort of, we're just going to inject faults into your system. And then the last thing I would ask is, do you know how old your instances are? Might be worth taking a look at that graph because we found that very informative. Great, thank you.